Hello everyone, this is LEELA SAINATH.GAMINI and my partner Sai Krishna Poosa. We are here to present a topic on designing and deploying a building-wide cognitive radio network testbed. Coming to the outline of our project: cognitive radio, wireless testbeds infrastructure, network infrastructure, complementary applications, future applications, and then finally conclusion. Coming to cognitive radio. Cognitive radio is a form of wireless communication in which a transceiver can intelligently detect which communication channels are in use and which are not, and instantly move into vacant channels while avoiding occupied ones. Generally, cognitive radios have the ability to monitor, sense, and detect the condition of the operating environment. Expanding the number of cognitive radio nodes allows us to full potential of network cognition to be realized. So if we increase the number of nodes, you can access to the entire network so that it gives us the accurate result, and it also allows us for many more applications to take advantage of CR algorithms that have already been developed. Coming to architecture for cognitive radio network, the figure we can see is that not a cognitive network that is deployed in a closed building or in a closed structure. It is the general form of cognitive radio network where you can see a antenna which act as a server and number of users, consider them as a clients, requesting or demanding the response from the client and the basic connectivity between them. And generally, cognitive radio networks are innovative approach to wireless engineering in which radios are designed with an unprecedented level of intelligence and agility. They can adjust their transmitting parameters. These cognitive radio networks can adjust their transmitting parameters such as power output, frequency, and modulation to ensure an optimized communications experience for users. Coming to explanation of this architecture, it is a wireless architecture which is a multi-hop, self-organized and dynamic network. To date, no attempt has been made to make a model of QoS architecture as a unified solution for CWAN, which is nothing but cognitive wireless network. In our research, our objective is to materialize a novel QoS architecture called C2net. C2net provides different prioritization to different traffic types in the presence of nodal mobility and licensed users. And this is realized by a number of distributed and cross-layer features of C2net, including topology management, congestion control, scheduling, and dynamic channel selection. And cognitive radio network, some of the benefits and its features are improved spectrum utilization, improved QoS. Many decisions may have to be localized, like distributed behavior. And coming to adaptations, is one of the radio that can impact adaptations of other, like interactive decisions, difficult to predict information. Coming to cognitive radio network testbed. What is testbed? The term testbed defines a platform for conducting rigorous, transparent and replicable testing of scientific theories, computational tools and new technologies. Cognitive radio network testbed, we call it as CORNET, was developed for the purpose of providing a resource that gives researchers the ability to move beyond simulation and beyond the single or dual node experiments. It means it provides the researchers or users to go more than what they can, to move more number of experimental researchers. It consists of 48 wireless software defined nodes whose focus is to provide a hardware and software sandbox for software defined radio and cognitive radio development. This represents the next generation of CR research platforms, and it is a unique testbed because of some of the reasons, like network topology, realistic and practical parameters. And coming to wireless testbeds, it is a testbed platform for conducting rigorous and transparent. As we already discussed this in the definition of testbed, recently a few testbeds have begun to add advanced reconfigurable nodes to their systems in order to begin the transition to the next generation of wireless research. The testbed we can see here in the figure is a 20 by 20 grid, which node separated by 1 meter. The research on orbit means an open access research testbed for next generation that we are using in wireless networks. It is a two-tier wireless network designed to achieve reproducible experimentation while also supporting evaluation of protocols and applications. The radio grid testbed, which is central to the orbit facility, uses a novel approach, as we already said in the above, and it can be interconnected into specified topologies with reproducible wireless channel modes, which is as shown in the figure. Hence, it is primarily focused on higher layer network protocols and has a very limited physical layer. And coming to testbed infrastructure, it consists of both the design for node hardware of the individual wireless nodes and design of the network topology for the testbed layout. The basic hardware components of initial version of the testbeds will likely include x86 servers and recent architecture and relatively high throughput. Testbed infrastructure requires very relaxed and relatively high throughput, and it has some Ethernet adapters, local storage device, and one 10x Ethernet switches. The basic software components are like Linux OS, QVMU or KVM, OpenStack, OpenSwitch. And coming to universal software radio peripheral, where we use this in the coming slides. So it provides hardware platforms or software radio. It connects with host computer using USB. It usually use it with the GNU radio software tool. It has a motherboard which provides following subsystems like FPGA, ADC, DAC. We know that analog digital converter, digital to analog converter, clock generations, and GNU radio. We're gonna discuss about GNU radio in the further slides by my partner, and its features are like 4 12-bit analog to digital converter, 4 14-bit digital to analog converter, 2 receivers and 2 transmitters, and it has bandwidth of about 8 MHz capacity, and it is a USB 2.0 interface, and it's auxiliary analog and digital input output system. Coming to network infrastructure, it's gonna be explained by my partner.
Hi everyone, myself Krishna Poosa. I'm going to explain that network infrastructure. What does mean by network infrastructure and what does network infrastructure means? Network infrastructure refers to the hardware and software resources of an entire network that enable network connectivity and communication, operations and management of an entire network. The original testbed architecture called for the both components of the wireless nodes, the processing platform of an RF front end to the allocate up in the ceiling. From this figure we can see that the locations of the RF protons of the wireless nodes uses a 3D model of the campus, and this allows us to certainly locate all the actual processing platform in a 45U server rack located within the first floor server room with less restriction access policies. In this, using Gigabit Ethernet as the interface between USBRS2 and the processing platform allows us to place the hosting in the remote control. It has a restriction that Gigabit Ethernet interface was the distance between the USBRS and the hosting process platform to be more than the maximum cable distance of 100 meters. And the other advantages of centrally located that processing platform includes easier management of the local network. It contains 12 nodes per floor for the total of 48 wireless nodes. Each is connected to the server that is in the ground floor. That means every server node is for first floor, second floor and the third floor is connected to the ground floor. Hence from the diagram we can observe that. Coming to the next slide, regulation testing usage. The objective of the regulation is to graduate the users of the testbeds while not transmitting or restricted bands, while still providing an open and flexible environment. It contains of two methods, and the first one is device drive of the nodes. and the second one is restricting transmitted is done through hardware contracts. For the first one, it has an disadvantage like fully access to the operation system and could simply remove the hardware construction themselves. Coming to the on the other hand, it has the disadvantage of the method that hardware filters that takes up enable space and the daughter board. The two methods are described as desired solution, and it has three levels like undergraduate level and the graduate level and the doctorate and behind, which is shown in the figure. Coming to the complementary applications, developing the testbed and bringing in online is only the first stage of this project. The difference between a large number of machines that are the openly available to use and the high performance research test beds is topically the applications that are available to the using test beds. The focusing on the applications of Cornet is both software defined and the CR research. These are the several openly available SGR software platforms that are regularly used. It contains of two most regularly used software platforms, including GNU Radio and the Free Software Radio Toolkit, and the other one Virginia Tech OSIS framework. And I'm gonna explain about the GNU Radio in the next slide. What is meant by GNU Radio? First, GNU Radio is a free software development toolkit that provides the signal processing block to implement software defined radios and the software processing system. It can be used with external RF hardware to create the software defined radio, or without the hardware it simulates like environment. It is nothing but the widely usage of commercial environment to support the both wireless communication research and the real world radio system. The GNU radio application themselves are generally known as flow graph, which are series of signal processing block connecting together. And coming to the Virginia Tech OSIS, it is nothing but open source software defined radio developing effect based at wireless. The project primarily goal that are enabled to research and educate in SDR and wireless communication. Coming to the next slide, the conjugate radio open resources system was developed as a framework to encourage in different types like the components that may include a conjugative engine, spectrum sponsors, policy engine, database, and many others. This type of architecture is very useful to the combine the remotely accessible test beds as such as Cornet. Going to the next slide, the future test bed requirements. In the first phase of the testbed development, we has created researchers as forces on SGR and CR researchers, and can explore other the air experiments on higher performance service. The testbed provides a more practical environment to work in the relative to communicate simulation of environment. However, it still lacks many aspects, preventing in the from fully environment all exploring all possible wireless environment and CR experiments. These are the equipments and software we are used in the software conjugative radio, like we are using signal function generator and cone shaped antenna, USPRS2, a power meter, NX client, and a MATLAB and the software Microsoft Excel. These are the future applicants that we had many applications to implement, but we took only the few applicants, like a 911 emergency personnel who needs to locate a vitamin taped into a building, and the next one, parents who need to locate their children in the crowded and the large buildings like mahals and the museums and etc., and locate the lost person items like the cell phones, keys, like in the malls or everything. Going to the next slide. Finally, this is the conclusion. On the software and management side, these users access considerations, network topology, standard software modules, and even legal restrictions must all be considered to create a researchers that enables current CR researchers to take their work to a new, more realistic and practical level. This is the future work we are thinking about, to find the maximum power level requirement to accurately locate the transmitter, and to find the maximum number of nodes and the distance between each one to accurately locate a transmitter. Thank you.